Well, we better go back to what's causing all this. The amount of forcing that's causing this warming is, we can divide it up into the sources of warming, and this is what IPCC has done, and they're called radiative forcing components. What's happening is, if say you put carbon dioxide into the atmosphere, it is actually like a greenhouse. It allows all the shortwave radiation from the sun to come down straight in, reach the planet, but the radiation from the sun causes the Earth to warm up, and the Earth then emits its own radiation, long-wave radiation, due to its temperature. Everything in the universe emits radiation at some level which depends on its temperature. So the Earth is emitting long-wave radiation with infrared, and the CO2 absorbs the outgoing infrared, so it's stopping the radiation from the Earth from getting out, but letting the shortwave radiation from the sun come in. So we're getting an imbalance, which you can express in terms of a difference in radiation between what's coming in and what's going out. And CO2 is the biggest single source of that radiation imbalance at the moment. But methane is kind of catching up on it. Okay, back again. So CO2 is the biggest. Methane is following about a quarter of the CO2 levels. There's some halocarbons still affecting the world, even though we've stopped using them. And then there's some, to offset it, there's some effects of clouds and aerosols, that's air pollution, which actually act against global warming. But the net result is that the total is about the same as the carbon dioxide alone. All the others have a minor effects. And that's increasing all the time because the CO2 level in the atmosphere is increasing, and as it increases, it takes out more of the outgoing long-wave radiation, and so that makes that balance worse, and so the Earth has to warm up to restore the balance. So you always get a warming. If you add CO2 to the atmosphere, it'll always absorb more outgoing long-wave radiation. That will always mean that the Earth has to warm up to match the outgoing and the incoming radiation. So it's a kind of high school physics that add CO2 to the atmosphere, you get warming. To deny that is kind of idiotic, and all the climate change deniers, including all the politicians, are absolute total idiots. I mean, they failed to... It's like saying that the Earth is flat because you can't see the bend. It's like saying that gravity doesn't exist. It's that kind of level of mentality that is really low. And so I can't believe that the people who say that CO2 doesn't have any effect on global temperatures, that they can believe that. Either they don't believe it, but they say it because they're in the pay of the fossil fuel industry, or if they believe it, then they're total morons. I mean, we're ruled by complete morons, up to and including the president. So that's my view of having studied. I mean, if you go through the physics of how CO2 causes global warming, there's no way that you can not see very, very simply that it does, and that the more you add, the more warming you get. It can't cause a cooling, or it can't do nothing. It causes a warming. So anyway, that's... but then, because therefore the more CO2 we have in the atmosphere, the worse our warming. And it's the level that matters, it's not the emissions, and that's the other frightening thing, that we get we can say we're reducing our carbon emissions and feel all good about it, but as long as we've got any emissions, more or less, we're increasing the level in the atmosphere because the carbon dioxide stays around for hundreds of years in the Earth's climate system. It doesn't go away. Like methane goes away, it oxidizes in a few years, but carbon dioxide doesn't. So it's not enough for us to reduce carbon emissions. We've got to actually stop carbon emissions, or get rid of some of the carbon that's already in the atmosphere. So that's something I'll talk about this afternoon. But as it stands, these are the villains, and who are the villains? Well, actually, we're all villains, but these are the emissions by different countries. It's about 5 years out of date, but we can see that the US has gone down slightly. Europe, that's the EUR, has gone down slightly, and this is the rest of Europe, has gone down slightly. So we can all feel good. Wow, aren't we good? We've reduced our carbon emissions. But the only reason they've gone down is because we transferred all our industry to China. So all the stuff that we used to make with efficient factories is now made with inefficient factories in China. So China's emissions have gone right up, and so have India's. So the net emissions of carbon dioxide continue to increase, even though Western Europe and the USA feels good about reducing their emissions. They've only just transferred their emissions to China and India. So the net is going up, and and we notice that the curve mentions cement especially, because cement is the worst stuff in the world as far as climate's concerned. We should never use cement for anything, because when you produce cement, you need a lot of energy to produce it. But at the same time, the chemical reaction that occurs when you turn lime and into cement produces carbon dioxide. So you're getting much more carbon dioxide produced per unit of cement than anything else. You could build houses out of glass or steel or bricks or wood, best of all, and it uses much less energy than cement. So concrete houses are a disaster, concrete buildings are a disaster. Unfortunately, China is the worst offender here, because they've got a state-owned cement industry which only, the people who run it only avoid being put into jail or beheaded or whatever by producing ever more cement. So all the new ghastly Chinese cities have all got 15-story concrete apartment blocks producing vast amounts of CO2 in their production. So it's a pretty sad story, and it hasn't changed. And so we are doing nasty things, and we're not even reducing our emissions. They're still increasing exponentially. So that's what we're doing, and we've reduced the area of ice in the world. This is the September again. I'm going back to the sea ice again, and the red shows what's actually happened, and the black shows the predictions of various climate models. So we can see that climate models are very inadequate and very complacent. So when scientists were, last night people were saying some things about scientists not being totally good, well, not totally honest, but I think the climate modelers, they're honest, but they don't pay any attention to data. So they've predicted this curve as being the volume of ice in summer, and you can see that there's still plenty of ice around in 2100 according to their models. But unfortunately, they weren't going to the Arctic themselves. They were sitting at a desk somewhere. So unknown to them, the actual reality was doing this. So we're down, in 2012, we were down to a volume of ice in summer, which matches what the modelers said we get to by 2100. So there's something really seriously wrong with climate models, and that needs fixing. Now that the climate people have acknowledged that they're up the creek. So I'm coming to the end of my this morning's talk. So I was going to sort of divide up and start talking about the impacts a little bit, and then carry on this afternoon with impacts. So what I've said so far is what the Arctic's done, but that sea ice retreat is having global impacts which are greater, much greater in fact, than the direct impact of the ice retreat itself. So I'll deal with just two of them, well, three of them, now, and then go on this afternoon to talk about some more. So if I run out of time, I'll just add it on to this afternoon's talk. So the first thing is albedo feedback, and albedo feedback is the direct effect that as sea ice retreats in the Arctic, it accelerates global warming because you're taking away white stuff, which is the ice, and replacing it with dark stuff, which is open water. So okay, the left-hand picture shows a typical summer scene in the Arctic where the ice is melting, and you can see that the open water is dark, the ice is bright, and the ice has an albedo of about 80%, so about 80% of the radiation that falls on it is reflected straight back up, but only less than 10% of the radiation that falls on open water is. So the contrast between ice and no ice is an albedo of 80% versus 10%. So as the ice retreats, suddenly, and the world gets darker, and that means the world absorbs more radiation, and it accelerates global warming. So it's a positive feedback. Positive not meaning good, it means making things worse. So the positive feedback of albedo change accelerates global warming. So that's the first direct effect of sea ice retreat. And this was calculated by in a paper in 2014 by Pistone, and they just looked at here's the Arctic in summer. The black stuff on the left used to be ice and isn't anymore. So you turn that area from white to black. What does it do? It adds a lot to the radiative forcing, 6.4 watts per square meter. It reduces the average albedo of the planet, and it's equivalent to having an effect on the whole planet equal to a quarter of the effect of the direct effect of adding greenhouse gases. So you're adding greenhouse gases, causing the ice to retreat, and that retreat is like adding another 25% to the warming. But in fact, that's inadequate, as I'll explain this afternoon, because it doesn't take account of the fact that the snow retreats as well. That adds another quarter. So in effect, we're adding a half to the global warming effect of adding CO2 to the atmosphere. We're making the effect half as bad again, because that causes the ice to retreat and the snow to retreat. So it's a sort of getting on towards a runaway. It would like to be a runaway global warming like Mars, but it's not quite reached that. But it's kind of frightening that the things we're doing cause an acceleration of the warming. We're causing a feedback, planetary global feedback, just from an effect in the Arctic. So that's why I'm feeling very concerned about the Arctic, because it's not just a local thing. It's not just glaciologists saying, oh dear, my favourite ice has gone. It's that ice is affecting the whole planet. Okay, here we are. Well, first, what are the effects? Well, first of all, that if we look at the temperatures in November of 2012, for instance, and we look at the top of the planet, we see big red splodge, which is a very large warming, a large warm anomaly that shouldn't be there because the ice hasn't reformed yet, whereas it normally does. So that's a big warming, which has another big albedo effect. So this is sort of typical of how the Earth is responding to this. here we are. And then the other thing, the second thing which I'll end on, is sea level rise, and that's that's most frightening because it's inexorable, because it's going on, it's accelerating. We're standing on this exponential curve where we look behind us and the sea level hasn't changed much. We look ahead of us and it's going up vertically. And the reason why this has been accelerated by the loss of sea ice is it doesn't directly affect sea level. Like when you melt sea ice, it doesn't change sea level because it's like melting an ice cube in a drink. It's already afloat, so it melts, doesn't do anything. But the thing that it does do is the retreat of the ice causes the atmosphere to be warmer over the Arctic. That warm air comes in over Greenland and warms the atmosphere over the Greenland ice sheet. So the Greenland ice sheet starts to melt, and that really does put water into the ocean and cause sea level rise. So here we see, well, that previous picture showed warm air coming in over Greenland in recent years. And then in 2012, for instance, we see that early in the summer, it was typical of a previous typical summers in Greenland. You get a little bit of melting around the edges of the Greenland ice sheet, but not in the centre. But in 2012, the right-hand picture shows almost the whole of Greenland was melting in the summer because of all the warm air that came in because there was so much open water around in the Arctic. So the open water in the Arctic leads you to warm air over Greenland. The warm air over Greenland causes the Greenland ice sheet to melt, and the melting of the Greenland ice sheet dumps fresh water into the ocean, and that accelerates global sea level rise. So we've got immediately a feedback between sea ice retreat and global sea level, which is a very, very serious one. And in fact, we now know how much mass is coming off the Greenland ice sheet because we've got a wonderful satellite called GRACE, which is a pair of gravity measuring satellites that move together a few meters apart over Greenland. And as they move over the Greenland ice sheet or over the edge of the ice sheet or over anything on the planet, the distance between the two satellites changes because one satellite encounters a different gravity field before the next one, and they move together or they move apart. You can calculate how much extra mass there is underneath you. So when you fly over a big ice sheet like Greenland, it will calculate how much ice there is, which is very helpful. You used to have to sort of stick stakes in the glaciers and things, but now you just measure it with the satellite. But that shows that this decline of the mass of Greenland is accelerating. Everything's going exponentially, so that it's not just linear decline, it's an exponential decline. It's losing mass faster and faster every year. And all of that mass that's lost goes into the ocean, and that all causes sea level rise. So when we look at sea levels in the world, we see a steady increasing predictions of how much we're going to get. So up to the year 2000, we had the blue line, which was just a small amount of rise. Then as soon as these effects on Greenland started, we had an acceleration. But the Intergovernmental Panel on Climate Change, which tends towards complacency, only had a linear rise of a few tens of centimetres, 20 to 40 centimetres, back in 2007. Then they were forced to acknowledge that Greenland is melting and that this rise is actually exponential. So their new estimates now take us beyond a metre. And the more observations that scientists do on Greenland and Antarctica, the more sources of rapid melt they see, and the more, therefore, the more water is dumped in the ocean, and the more sea level rises. So the sea level rise predictions are going up quite rapidly, and that of course has terrible implications for cities, coastal cities, and also for coastal areas in poor countries like Bangladesh, for instance. This is this is not a good picture, but it's one I drew quickly. If it's that the bad effects of sea level rise are worse than you think, because when you think sea level rise of a metre, for instance, if we're in a Western country in Europe or Holland or something, you just raise the heights of all the sea defences by a metre and everything stays the same. But if you don't raise the heights of the sea defences, then that extra metre is going to really do you a lot of harm. And so a lot of cities don't do that because they can't be bothered, they haven't got the money, or they don't want people to know that all their coastal real estate is going to disappear, and this will upset the economy. So we find that the effect is far worse than you expect because of the properties of the bell curve, the normal distribution. If you look at this curve, for instance, imagine there's a spot on the sea surface there, and the black line is the distribution of heights of the water at that sea surface point in time. Depends on the state of the tide, winds, currents. It changes with time. And so you have that bell curve is the height of the sea surface there. Now supposing some distance above the average, you cause a flood disaster. And that's that black bit. So the probability of your flood is the area of that black curve at the top end. Now, supposing you now increase sea level, the whole curve moves up, but the area that's above this critical point becomes much bigger. So you think you're having a small increase in average, but the increase in the probability of a disaster goes up much faster. And that means places that can't raise their sea defences, like Bangladesh, around the whole coastline has got millions of people living on it. 20 million people live less than 6 feet above sea level. Those 20 million people get occasional floods from the storm surges in the Bay of Bengal. But if the sea level, global sea level goes up, those floods will become much more frequent. And those floods kill a few hundred people perhaps in Europe or America, but in the Bay of Bengal they kill hundreds of thousands of people, and those disasters will become much more frequent because of global sea level rise and poverty, which stops people who live in crowded coastal areas from raising the heights of their defences or moving inland even. So sea level rise is a disaster primarily for poor countries, but it's a economic disaster for rich countries. I mean, it will mean Miami will have to be abandoned, and already New Orleans ought to be abandoned. So that sea level curve is inexorable because it doesn't, even if we reduce our carbon emissions, it will take a long time before the rise of sea level slows down. It's like because it's so many sources of it, so much melting of the two ice sheets causing it. So there we are. That's sea level rise. That's just one of the bad, perhaps the worst effect apart from the direct warming. So I'll carry on this afternoon with hopefully continued gloom, but with some hope of what we can do to save ourselves, which I think we can do something.